Hi, everybody. I am Mrs. Alexander, as you know, and I am here to go over the More Practice and Homework book with you for lesson 2 of module 9. So let's get right to it. It was a little bit of a tricky lesson as far as the actual drawing of the model, right? But otherwise, multiplying the fractions was not the tricky part that we found in class. So let's adjust a little bit here and see if I can't make this look a little bit better for you. All right, we'll see how that works. So we are multiplying mixed numbers. Here we have a situation. Trail running is an exercise that involves running on trails instead of on paved roads to reduce the impact on ankles and knees. Ooh, that's a good thing because you all know about my knee right now. Samantha runs on the lakeside trail. She runs 2.5 times around the loop and then walks the remainder of the way. How far does Samantha run? Write an equation to model the distance. So if she is running 2.5 times the 2 1/4 mile loop. She's doing that 2.5 times. So my words right there should have helped you. She's going 2.5 times around a 2 1/4 mile loop. So there's our expression right there. We can go ahead and do that work. I'm trying to see, I think my marker might show through on the other side, so I'm going to change my pen here. As you remember, hopefully, if you're going to multiply mixed numbers, we're going to rename them as fractions greater than 1, improper fractions. So we would have 5/2 times 9/4, which is going to give us 45/8. Now, we have that as an improper fraction. We're going to revert it or rename it back to a mixed number. 8 goes into 45 how many times? 5 whole times. 8 times 5 is 40. That leaves 5/8. So how far does Samantha run? She runs 5 5/8 miles. All right. Here is where the model drawing came into play. Go over it with me, see how you do, and remember that for our mini test next week, we will not be drawing the model out unless you want to use it. Jiren is making a rectangular banner for school. The dimensions of the banner are 1.5 yards by 1 3/4 yards. What is the area of the banner? We're going to use the visual model to show the area and then write our equation and model. So remember, we have more quadrants. We have these 4 spots because we're working with numbers bigger than 1. So just 1 wouldn't be enough. We need more than 1 to show 1.5. We need more than 1 to show 1 3/4. So I'm going to label here 1 1/2. And if you remember, we're still going to use that denominator to tell us how many parts. So at the top, I'm going to split that into 2. And at the bottom, I'm going to split it into 2. Now, how many halves is 1 1/2? How many halves is that? That would be 3 halves. So I'm going to color in 1, 2, 3 of those rows that I have in halves. 3 halves. All right. Then I have the 1 3, oh, wrong color. 1 3/4 right there. If I'm going to show fourths, then I'm going to divide this now. I remember I have 2 sections, 2 top, 2 bottom, and I'm going to split those into fourths. 1, 2, 3, 4. 1, 2, 3, 4. And how many fourths do I have if I have 1 3/4? I have 7 fourths. So I'm going to shade in 7 of those columns. 3, 4, 5, 6, 7. All right. So there we have our model now completely drawn. And what I want to look at is the parts of the model where I shaded twice. And I used blue and yellow. It didn't really turn green, but I'm outlining it with the green to show. That's where I shaded twice. So my answer using the model, the first thing I want to know is how many total of those equal size pieces do we have? We have 1, 2, 3, 4, 5, 6, 7 by 3. So I have 21 of those pieces. If I just pay attention to one of these 4 quadrants, how much is each of those? What is the area of each of those boxes? Well, I'm just looking right here. So I have 8. So this would be 1/8. So I have 21 of those 1/8 area boxes, which would be 21/8. That's what the model is showing. If I rename that, it would be what? 8 goes into 21 2 times with 5/8 left over. All right. So that's one way you could show that equation. You could also write 1 1/2 times 1 3/4 and use the renaming if it's a mixed number and I would like it to be a fraction greater than 1. Improper fractions. I have 3/2 times 7/4, which would be 21/8. Look back here from our model. We would end up with that 2 5/8, and we are talking area, so yards squared. Okay, I told you in class, this was also something when I first looked at it, I really had to think, okay, what are we doing? What is it showing? Now that I've done it, of course, I've done it more because I have 3 math classes and I've done it over and over and I practiced ahead of time and now I'm doing this one, but I'm feeling better and better about it. So give it a chance. If you see it somewhere coming up, we talked about IAR testing or anything like that, give yourself a chance to recognize it and be familiar with it so you can use it or you can read the models like we're going to be doing coming up. All right, here we go. Let's multiply. Here we have 8/5 times 5/2, which would give us 40/10, which would equal a whole 4. Here, and if you need to pause, I'm going to do these a little bit quicker. If you need to pause and check yours one at a time, that would be fantastic. I don't want you to try to go as fast as me, maybe. I'll try to slow down here and remember, but I want you to take your time and do it and then check your answers here. So Columbia C, 4 times 3 is 12, plus 2 would be 14/3, times 3 times 2 plus 2, 8/3, which would give us, let's see, 8 times 4, 32, 8, 112/9. Ooh-wee, which would be 9, 22, let's see, 18, 4/9, I think. I'm going to go off to the side and check my work there. 112 divided by 9. 9, 10, 11, 2, 18. I think I did it. Okay. Here we go. 3 5/8, 24 plus 5, 29/8 times 3/2 equals, let's see, 29 times 3. I'm working down at the bottom. Sorry, I'm getting a little wonky with my paper with this document camera. 7 would be 77/16. 27, 29 times 3. All right, double checking my work because I got a little off track there. 29 times 3, 27, 6, 7. Oh, I think it would be 87. Sorry. 87. 16 into 87. 87 divided by 16. Let's see. What if I went with 6, 5 maybe? That gives me 80 and 7/16. No, it does not. Look at that. 5 and 7/16. Oh, goodness. I would love it if these, boy, that 80, I was like, that's not reasonable. I would love it if this company would give more space to work on some of these pages. 5 and 7/16, my friend. You almost got to call me on a challenge there. Sorry. 2 1/3, 7/3 times 2 3/4, 11/4 equals 77/12. 12 into 77. 12 times 5 is 60. 12 times 6 would be 72. 6 5/12. 3 1/5 times 1 2/3. 16/5 times 5/3 equals 80/15. Let's see, 15 times what? 5 would be 75. So 5 5/15, which could even be simplified more to 5 1/3. And 11/2 times 15/4 equals, 11 times 15. 11 times 15, 165/8, which would give me 20 5/8, I do believe. Okay. So hopefully you paused, you came back to check the answers. Here they are. All right. Hope I don't get caught in a challenge. Number 9, Jonathan uses this area model to show the product of two mixed numbers. What equation models the product? So let's think about this. If we have 1, 2, 3, 4, 5, 6, 7, 8, we have 8 rows. So that means we have eighths. And we have 1, 2, 3, 4, 5 of those eighths filled in. So 1, 2, 3, 4, 5, 6, 7, 8. That's not going to be right because remember, if we're using these quadrants, that means I have to have 1 and how much? 1 and. So let's see. Oh, you know why? 1, 2, 3, 4. I was counting both. Remember, with these quadrants, I'm looking for my denominator to be, if I'm just looking in one of those quadrants. So that would be, we divided them into fourths. To think back about how we created these models. And then I had 1, 2, 3, 4, 5 fourths. That's better. That's going to be a number greater than 1 because it is an improper fraction times. Now I'm looking at 1, 2, 3. Those are my thirds. And I have 1, 2, 3, 4, 5 thirds equals n. I could also write 1 1/4 times 1 2/3 equals n. That would be another way to show that model. And then we would get our answer we could solve. Woo! Telling you, these are killing me, smalls. Here we go. Last one on this side. Kara's muffin recipe calls for 1 1/2 cups of flour for the muffins and 1/4 cup of flour for the topping. If she makes half of the original recipe, how much flour will she use? So if she needs, the muffins need 1 1/2 cups and a 1/4 of a cup, and that's going to give you the muffin and the topping. We would need to change 1 1/4 to 1 2/4, so we could add it to 1 1/4, and we would get 1 3/4. Now, that is what the recipe calls for. She's only making 1/2 of that recipe. 1/2 of 1 3/4. Okay, this one's kind of a two-stepper. Like on our last module test, there was one question that I said you need a little bit more. You have to find the answer first for how much the recipe calls for before you can then divide it in half or split it in half. Find 1/2 of it. So then I'm going to go back to my page. 1/2 of 1 3/4 equals 1/2 of Columbia C, 7/4 equals 7/8. So she's going to be using 7/8 of a cup of flour. And that is your final answer if she uses half of that recipe. Whew. All right. Let's see what happens on this test prep side. Which mixed number is equivalent to 3 1/6 times 2 1/2? And again, pause the video, come back to check answers. You do the work. Let's see how you would do if these were questions on a test. 3 1/6 would be 19/6 times 2 1/2, 5/2 equals 19 times 5, 95/12. Well, none of these have been left improper, so I need to do 95 divided by 12. I'm going to go with 7, 14, 84. Oh, look how close that was. My remainder is the numerator. My divisor is the denominator. 7 11/12. Letter D. All right, that worked out good. Nandani has 6 cups of flour. Her muffin recipe calls for 1 1/2 cups of flour for one batch of muffins. How much flour does she have left after making 1 1/2 batches of muffins? She has 6 cups. That's what she's starting with. The recipe, she needs 1 1/2 cups for one batch. She's going to make 1 1/2 batches. So what is, let's see, one batch would be 1 1/2 cups. That's one batch. I need half of that. 1/2 of 1 1/2 for the other batch. 1/2 of 1 1/2 equals 1/2 of, let's see, 3/2, which would be 3/4. So 1 1/2 plus 3/4 is going to give her the batches. So I need 1 1/2. If I'm adding fractions, now I have to go back to common denominators. 1 2/4 plus 3/4 is 1 5/4, which is 2 1/4. That tells me how many cups she's using. I'm glad I didn't just look because that answer is here, but it says how much flour does she have left? So that means she started with 6 cups. This is a lot, guys. I hope you're hanging in there. 6 cups. Now she's using that 2 1/4. So now I have to do a little bit more work here. I have to do this subtracting. Remember how we did this? There are a couple of ways. I'm going to rename my lead whole number because I need some fraction parts here to subtract from. So I'm going to rename it as 5 4/4 minus 2 1/4. That's going to leave me with 3 3/4 of her flour in that bag. There's the answer, letter A. So if you stopped at 2 1/4, you were on the right track. That's how much flour she used. So you were in the right direction. You just have to keep track of what our information was telling us. And that can get a little tricky sometimes, I'll admit. Good. I hope you hung in there for that. If you have questions, please bring them to class. We can go over things again in class. Each day, Jared walks 1 3/4 miles to school and back home. Isaiah walks 1 1/3 times as far as Jared. How many miles does Isaiah walk to school and back home each day? Write an equation to model the problem. So Jared walks 1 3/4 miles. Isaiah walks 1 1/3 times as far. And we want to know how far Isaiah walks. So does Isaiah walk farther or less than Jared? He walks 1 1/3 times as far. So he's going farther. So we're going to say 1 3/4 times 1 1/3. And for that situation, I actually wrote that backwards, didn't I? It's 1 1/3 of that 1 3/4. It's going to give us the same answer with our multiplication. So then we have 7/4 times 4/3 equals 28/12. 12 goes into 28 2 whole times. That would be 24 and 4/12 left. So we could say 2 4/12 miles. If you simplified that, it could be 2 1/3 miles. Either of these answers would be acceptable. All right, number 14. Cynthia is using tiles that measure 1 1/2 foot by 1 1/2 foot to tile a rectangular countertop that measures 8 1/2 feet by 3 1/2 feet. How many tiles will she use? So the tiles are 1 1/2 foot by 1 1/2 foot. Her countertop is 8 1/2 feet by 8 1/2 feet. So how many tiles will she use? Well, if we have 8 1/2 by 3 1/2, let's see what happens. 8 times 2 plus 1, 17 halves times 3 times 2 plus 1, 7 halves equals 17 times 7 equals 119/4. If these tiles are 1/2 by 1/2, they are all 1/4. So that means how many fourths will she use for the tile? Because this is the area of her countertop. This is the area of one of the tiles. How many fourths or how many tiles will she then use? That's our 119 tiles. All right, so that numerator tells us how many of each, if each one of them, if these are her tiles, that's their area. This is the area of her countertop. She's going to need 119 of those 1/4 tiles. All right. I love this spiral review. This has been coming up in lessons again and again, so it's good to refresh. A building measures 45 feet tall. The building is rescaled as modeled by the expressions shown. Use shorter, taller, or same to describe the height. So remember, we're looking at, if we have 45 feet, we're looking at what we're multiplying 45 by. Is it greater than, less than, or equal to 1? 8/6 is greater, so that means that this rescaling would be taller. 5/3 is greater than, so that means this one would be taller. 2/6 is less than 1, so this one would be shorter. 6/6 is equal to 1, it's going to be the same. 4/5 is less than 1, it's going to be shorter. and 8/8 is equal to 1, it's going to be the same. So glad that was part of a spiral review. With that keeps coming up in class, so I love it. All right, that's it for this lesson. It was a lot. If you need some more practice or to go over things, look at IXL. Come to class with questions. I'm more than happy to talk about it in class or even have a working lunch with you if that's something you would feel comfortable doing. All right, so keep working hard. I will see you next time.